Uh-oh, looks like we got a bad boy on our bench. Look at this thing. Isn't this a treat? Harman Kardon Citation 19 amp. Look at that beautiful, stunning, simplistic design. I love it. I love it. Absolutely love it. This front plate is like a 1/4 inch thick. And it has a finish on it that's superb. And it has like, I don't know, it has like a purple, almost a purple, deep purple. It's obviously a charcoal black, but it's got like a, maybe it's the LED lighting I'm shining on it, but wow, look at that. And you know what I love about this thing is it's all party in the front and business in the back. Look at this thing. They needed some more room, so they had a little sheet metal work here. Isn't that something? And you got 2 power amplifiers. This is a dual monoblock design, kind of like some of the other Harman Kardon stuff, but this one's bridgeable. You can run it stereo mode or bridge mode. Inputs and your outputs. That's it. That's all you need. I don't even think they put a fuse back here. There's no fuse underneath. Nope. Look at that. Okay, I picked this up for a good price because the previous owner claims one of the channels is out. But I got a confession to make, because when this arrived, I plugged it in and tried it out, and as far as I can tell, I didn't hook up speakers. I hooked up a scope, and from what I could see on the scope, both channels were working. So this is going to be an easier repair than I thought. But there's still problems with it, and we'll go and I'll show you what a few of the problems are. Cosmetics. This top is a little bent here. I can straighten that. Just cleaning. Everything needs a good clean. It's all like these holes are all filled with dust. As far as the front goes, it's pretty much ready to go. These buttons feel weird to me. Maybe they're okay. But we're going to take this all apart and check it out. I have a feeling I know why the previous owner said one of the channels is out. Didn't say left or right. I got it plugged in now. Let's turn it on. And I don't know if you can see that, but I got some LEDs lighting up here. Now I don't know if that's a stray signal in with the amplifiers or if that's a fault with the indicators and the meters. But we're going to get into that. We're going to figure that out. It's got 2 settings, and then when you put it to test, this side is not working, and that's what makes me think. That's what makes me think that there's something wrong with the metering, and obviously an LED is out. But for right now, I just want to check the DC offset on this thing. So, right channel, let's see what we got. 42 millivolts. Left channel, 25 millivolts, 24. So that's pretty reasonable for an amplifier that is this age. And if it's never been aligned, worked on, tweaked, that is actually pretty good. Just from the aging of the components, you get that much offset. Wow. Well, I'm excited to get into this. Let's take the lid off and have a look inside. So with everything else Citation, this thing's no exception. It is made out of heavy gauge steel, and even the lid has to weigh 4 or 5 pounds. But yeah, look at this. Incredible. It looks like it's untouched. I don't think anybody's done any repairs to this, to the amplifiers anyway. Let's have a look. everything looks untouched. Look at these amplifier modules, the size of my hand. So the previous owner also threw in a little treat for me. I never expected this, and it was a nice gesture on his part. He threw in an original service manual. Let's go over some of this stuff here. So this amplifier is 100 watts minimum RMS per channel. Both channels driven at 8 ohms, 20 to 20K. 0.08% THD. So that's the rated output. It's 100 watts. Power bandwidth from below 5 Hz to beyond 65 kilohertz, less than 0.08% THD, driven at 50 watts. That's pretty impressive, 50 watts and 65 kilohertz. Frequency response from below 5 Hz to beyond 50 kilohertz, plus minus 0.5 decibels. That's pretty flat. And that's quite a range to have it that flat. That's well, look at here, they go on to say 5 Hz to beyond 140 kilohertz, minus 3 dB. That's what everybody else measures at, minus 3 dB. Square wave rise time, better than 2 microseconds. And it says here, phase shift less than 10% at 20 kilohertz. It's impressive. I guess they paid attention to detail when they laid out these boards. You know, signal propagation and whatnot. Slew rate greater than 40 volts per microsecond. THD is 0.08% from 250 milliwatts to 100 watts through the whole range. Intermodular hum and noise. It's kind of a small unit, 16 inches wide. Usually most stereo equipment is 17, but this one's a little narrower, 16, and it's 5 1/4 and 14. But it's got a kind of a small size. You think for a 100 watt amplifier, I think would be massive, but it's kind of petite. The thing weighs 39 pounds. And then it says the unit may be bridged to provide 220 watts from 20 Hz to 20 kilohertz with less than 0.16 THD and a single 16 ohm load. They don't have any mention of 4 ohm loads on this, but I heard this is a very stable amplifier, even down to 2 ohms. You can really pump out the current, and it has dual devices in the output stages, so you know it's capable. Okay, I spot a problem right away. This little board here has on the underside has a connector. It's an 8-pin connector, and this one, possibly this one, maybe that one, and that one, they're cracked. So I'm going to solder that. This is the back side of the LED display. So let's just pop some solder on these. Left my solder iron idling for too long. Let me see if I can do this with not being in your way. See what this does for the display. This board, by the way, is double-sided, so that's why it kind of surprised me to see that. At least I think it's double-sided. I see a pattern on the other side. Okay, let's try this out. Okay, let's try it out now that we soldered up those bad joints. Oh, those two LEDs aren't on anymore. Off. 1, 2, test. Oh, look at that. Looks like we have dirty switches though. Yeah, that's dirty switches, alright. So all we got now is the dirty switches and a burned out LED, or a dead LED. Cool. Before I go any further, I want to have a look at the underside here, the peek at the undercarriage. See what's going on. I noticed there was 2 screws missing from the bottom. That doesn't mean anything because they could fall out. These aren't particularly tight screws, but let's see what's going on here. So yeah, not much going on. It's pretty much what I expected. Couple fuses. This is that 8-pin connector that was cracked from the other side. Yeah, it is double-sided here. I think I'm going to have to resolder some of these switches too. I think they're... Somebody's been in here. The fingerprints. Here's some fingerprints. Fingerprints. Somebody's been in here before. And I think they changed the fuse. Let me unplug this thing first. Now that we're dead. Yep. Looks like somebody soldered in a fuse, because there's a fuse holder here. But what they did is they tacked a fuse over top. Interesting. So here's the original. Here's the replacement. And the stickers for the fuses are missing. I'll have to replace those. A little bit of dust. A couple more fuses down here. 1000 microfarads. We'll check all these caps. Yeah, I really like the way they designed, the power supply of this thing. It's a nice, clean layout. Heavy conductors, and that's exactly what you want to see, a high current supply. Okay. I think I want to take this outside and blow a lot of this dust out. There's dust everywhere. Let's blow this thing out. I'll take these covers off too. And then we can get rid of some dust on this thing. Okay, before I go too much further, what I want to do is I just want to check the health of these capacitors. I'm just going to run them on my tester to see what tight. To see what they're doing. They are old caps, and if we can replace them now, we should do it, I guess. But that's going to be quite a cost. These capacitors are not cheap. They're only 10,000 microfarad. But if they're bad, that gives us a chance to do an upgrade and a replacement. Take this one off. Oh. They use like 12 gauge copper. Oh, that one cracked now. I'll have to resolder that. Doesn't want it to go. Okay, this screw out. So what I'm doing is I'm just removing one of the connections from one side of the capacitor. Pull that away, pull this away, and then we can get a good reading on these. That one's pretty much dead. Let's try this one. Alright. So we're measuring about 11, just about 12,000 microfarads. ESR is down. I didn't expect it to be high ESR, that's for sure. I see that's a good cap. That is a good cap. Let's try the next one. 10 volts. Let's see, we got a resistor here, we can discharge this. I got a 10 ohm resistor here. Just going to put it across. Okay, it's better. This one reads 14,000 microfarads. .6. Let's discharge that a little bit more. 1.5 volts. Let's get it down to nothing. Okay. $13,000 microfarads, 13,500. That's pretty good. I'm kind of impressed by this. So, looks like we're going to reuse these caps. Half a volt should be okay. $13. So we only have the one that showed up around 11, but the rest of them they're all good. We're not going to do anything with them, but I just want to make sure, confirm that they are good. And we'll have to fix this cracked solder here, put this all back together, and fix it up nice. So I was just having a gander at the fuses here. These are two 1 amp slow blow fuses, but they have 1 amp single filament in there. I think these will be fine. All this little circuit does is it drives the display board. There's no other purpose for it. But there is a problem here. This one's been replaced. This one's been replaced too. Somebody slapped in a 4 amp 250 volt fuse, and the schematic specifies, because the stickers are both gone here, they're both disintegrated to the point where you can't read them, but these are supposed to be 2.5 amp slow blow. So I have the proper fuses here now. 0.25 amp, yep. That's the right one there. I'm going to desolder this one and find out what this is, because it could be anything. Found a 4 amp where, let's see if I can get this out. Sure, I made a mess of it. Hang on, I might have to take that fuse holder out of there. Let me do this first. Take the screw out. wiggle this out a bit so I can get a look at it. Where's all my tools? I don't know why they did this. They soldered a fuse in where it should be just plugged in. Okay. $250 Where's the current on this? MDV3. So it's still another wrong fuse. But I have the correct one here. I'll put the fuse holder back. Check those connections. I'll put the fuse holder back and I'll pop the right fuse in. So removing the power amplifier module itself is pretty simple. There's one Molex connector for the input signals. 2 wires for power and 1 speaker output. They're all on spade lugs. So those are all disconnected. So everything on this side is disconnected. You need to remove the thermal switch from the TO3 transistor because there is no provision for unsocketing that. And then it's just a matter of removing 2 screws on the bottom, and the entire module just lifts right out, heatsink and all. Let me see if I can get this. And it's completely detached. So I'll take these modules out and I'll work on these first. They're going to get a overhaul. They're going to get fully recapped. I'm going to make sure there's no cracked solder joints on the underside. All these caps are going to be replaced. I'm going to go remove these mica insulators and put sill pads on all these transistors. Brand new sill pads. Yeah, so it should be fairly quick and easy. I'll get on with that. Okay, so what I did is I removed the display module or assembly from the amplifier, and I'm just taking a look at it now. We already found cracks along this connector. I soldered up. Now there's also another connector here. If I have a look at these, there's 1, 2, 2 cracked ones for sure on that side. On this side there is 1, 2, 3. 3 cracked ones. So let's solder these up right now. They are, the pads are pretty small for the size of pin and the, the amount of stress it goes under, so it's no surprise it cracked. Let's just clean this up. They could all use a cleanup. Okay. Now that's fixed. What I'm going to do is I'm going to remove these 4 switches from this board, and well, maybe I can clean them without removing them. I'll try cleaning them without removing them first. I don't like see, why is it doing that? I have to glue these on because they're popping off. See? Okay, I'll have to glue those buttons on because they're loose. You're going to lose one eventually. Yeah, they're all loose. And look at the oxides here on the silver plating. It's all black. These switches definitely need cleaning. Okay, now we had a dead LED, so let's test some of this stuff out. Was it this one? Okay, let's see what we got here. Okay. Let's try this. So that one's good. 1.7 volts, 1.7 volts, 1.6.6, 1.63 volts. Open circuit. Open circuit. 1.67 volts. Okay. So that one LED is open. That's why it's dead. What I'm going to do is I'm going to see if I can find 4 LEDs the same and replace all 4 of these so they have the same color, the same brightness, and the same look. So let's see if I can dig something out. Alright, so I got 4 LEDs selected that are approximately the same color. And what I'm doing is I'm inserting them now. Make sure they're orientated right. The flat is the negative, and that goes towards the center of the board. Just like that. So what I do to these LEDs are flopping around before I solder them is I put this back, and this aligns everything perfectly, and then I can flip it over and do my board soldering. And then they stay aligned when you remove it. Okay, I think it's time to do a little testing. What I can do is I can plug it into the chassis and use a power supply because it has plus minus 12 volts on this. Probably because there's 2 op amps here. There's LM 741s on both ends, and they need a plus minus supply, and they have plus minus 12 volts to supply this board. So what I'll do is I'll just hook it back up and try it out. So what I'm doing is I'm just working through these switches, and instead of desoldering it from the board, I just decided to try working at it from the top. What I have to do is what I did yesterday is I took contact cleaner, this stuff, and I sprayed it in each one and worked it And now I'm going to put some deoxit in, but I don't have a spray deoxit. What I have is the concentrate, 100% solution. So what I've done is, well, here, let's just check some of these first, because some of these switches are bad in the sense that they don't work at all. Which ones have I worked on? I worked on these two. And let's test them out now. Got my continuity tester. That one's working. That one's working. So the deoxit's working on these switches. These, if you look inside here, you can't see it on the camera, but it's just as black as it is outside. This is all oxide on the outside here. So I've done these two switches. Let's check this one as well. That one's working. And then this one I got obviously disassembled. This one I'm going to try out. This one hasn't been cleaned yet. Or it has been cleaned, but it hasn't been deoxed. This one's flaky. See? It's not working. It's not working 100%. So these two I still have to do. So I'm just going to show you what I'm doing here. Is I disassemble the switch, and there's these two sliders. Yeah, of course. But you can see after I sprayed the contact cleaner in yesterday that these switches are all dry inside. There's no lubrication whatsoever. Everything's dry. So what I'm doing is I'm just going to give it a drop of deoxit. Not even a drop. Just enough to get the contacts coated. And how do I want to do this? I'm going to try it this way first. These knobs are in the way. Okay. The hard part is getting this back together again with it. There, I think I got it. Just work it a bit. Okay, put this in, this will lock it. I just don't want it flying across the room while I'm trying to. Come on, get in there. There we go. Okay, that will lock it. Let's try that now. This one was really bad. It wasn't making any connection on the one side at all when I tested it with the continuity. Let's try it one more time, see if that's come back. Still flaky. That switch might be bad. Still not good. Yeah, see, it's not even working. I'm just going to work this and hopefully the deoxit will get to that. We might have to replace the switch if it doesn't start behaving. Seems to be working a little better now. It's getting better. Okay. I'm going to close this switch up. Lock it in. Just bend the tab slightly. You don't need to go crazy. If you ever need to go into these switches again, you don't want those tabs breaking off. And the last one here, I'm going to have to get into this somehow. Straighten this tab. That tab. And pull this out. What I did is I just got a chunk of plastic and one that would fit in here, and it would, what it's doing is it's blocking the locking bar from closing. You can see that. So I stuffed a piece of plastic in here to hold the locking bar open, and then all the switches won't lock. Otherwise I'd be fighting this locking bar. So I'll put that back in. There, just to hold it open. Now I can pull off this. And everything comes apart. These contacts are just a very thin sheet metal folded over, and they're very fragile, so you don't want to be forcing these in any way. I had a problem with one switch where it wasn't quite lined up when I was putting it back together, and it crushed the one side, so I had to take it apart and reform the leaf into what resembled a contact again. So let's try this here. Okay, I think we got it. I think we're in. And these switches are common. You see these all over the place. You can do this on any of these like switches. For example, on that Harman Kardon HK725, that preamplifier, it's just loaded with these switches. There was 28 of them, I think, total. And I had to disassemble every switch and do this process of cleaning and relubing and deoxing. And the result was good. Okay. Let's put this. All right. That switch is working good. This one still concerns me though. Let's test this one out again. It's getting better. Okay, so we're all good. all 4 switches are done, cleaned, deoxed, relubricated. Close this switch up. And I saved myself desoldering 4 switches. Pull this out. There, 4 clean switches. Now, these buttons, let's try this again. These buttons were coming loose. Here, I'll show you what I was... Where's the last one? Now watch, I'll push all these buttons home. And just from use, see how the button pops off? Pops off, pops off. This one really pops off. Okay, sorry for the interruption, but what I want to do here for these buttons is every time they pop off, they're loose, right? So they want to fly off. And surprisingly, these buttons haven't disappeared because they're all doing that. And then they have a weird feel to them, like you feel. So what I'm going to do is I'm going to glue them down. I'm just going to put a dab of hot glue at the base. I don't want to go crazy with hot glue because I want to be able to pull these buttons off if I have to. But I'm just going to put a little blob of glue, and just to keep it stuck on there so they don't fly off. It don't take very much, just a little bit. Okay, so I'll let that cool, and then I'll cut off all the excess, and those buttons will be stuck on. They won't be popping off anymore. Okay, so what I want to do is I want to test this board for functionality. Make sure all the LEDs are working. Make sure the switches are working. What I'm going to do is I'm just going to plug it back into the chassis. Let's see here. Plug this in. Now, I've got both power amp modules out and disconnected. These wires here are speakers. This is plus minus 55 volts. So I'll make sure nothing's shorting and everything's disconnected. Okay, good. I'll move this around here and plug this in. Okay, let's turn the power on. Okay, we got power, both lights are on. So we got all our LEDs going. Everything looks good. Everything looks good. Still got a couple of LEDs that aren't quite up to brightness. I think if I was going to do this again, I'd probably put all brand new LEDs in. Because, you know, these are 40 some plus years old and they're aging. And let's shut the lights off here. You can see that. Got fairly consistent brightness. Got a few that might be a little dim. Overall, I think they're good. This one has a different color. This yellow. And it's never been changed. Well, I think I'm going to leave it at that. Shut the power off. Yeah, I'm pleased with that. I can put it back together. Alright, so I've been busy working on these power modules, cleaning them up. What I did is I removed the mica insulators and replaced them with sill pads. I think it's going to be a bit of improvement, I think, for the heat dissipation. The heatsink compound wasn't at that point where it was starting to cake up and dry, but it was getting there. So I think this would be a good move. Get rid of that old stuff. I could have fixed up the old mica washers and cleaned them up and used them again, but we'll go this way, I think. Now, I've done a few things here. Replaced a couple of capacitors in the output circuit. And this board, driver board, received new capacitors as well. And I replaced a couple of 1 microfarad all electrolytics with film capacitors, just to make sure that those are going to be stable for the rest of the life. The circuit's good. I did find a cracked solder joint on the input pin, and that I found it on both modules, believe it or not. Both modules input pin was cracked, so I soldered that back up. I don't know if that was causing problems for the previous owner or not, but it won't now. Everything else is pretty much untouched. There was really no problems other than that cracked solder joint. And old caps. The caps, I tested them. They tested okay, but being 40 plus years old, I didn't want to leave them in any longer. These transistors have date codes from the middle of 26th week of 1978, and I think that's the newest one. So it gives you an idea when this was made, the late 70s. And you know, that's 42 years old now. So, but anyways, time to reassemble. And I think I'm done with this one. What I'll do is I'll reassemble this and then continue on the next one. I have to replace all the sill pads, and we'll get that all fixed up. But for now, this one's done. I just gotta reassemble, and then we're gonna put it aside. And once I'm done with these modules, I think it's time to power it up and start testing. Everything else is finished, so yeah, it's coming along nice. Let's have a quick look at the schematic for the Citation 19. Power supplies, it's pretty basic. We got 2 transformers, 1 for each channel. There's 2 secondary windings on each transformer. One's not used, and 1 is used. This here is the power supply for the display board, and that's all it supplies is a plus minus 12 volts, a low current, just enough to light a few LEDs. Each channel is fused 2.5 amps, and then each channel has its power on indicator. So if a fuse blows, that light will go out. Pretty basic. You got bridge rectifier, 2 10,000 microfarad 85 volt capacitors, and that derives your plus minus 55 volt supply for both channels. The amplifier itself is nothing spectacular, electrically anyway. Input, your bridge stereo switch, which configures your inputs for bridging. And aside from that, the amplifier itself is contained within this. You got your long tail pair at the input, voltage amplifier section, and then your output section. and the left channel is not drawn here because it's identical. This area here is all the heatsink and the circuitry contained within it, and you have 4 driver transistors for each channel. They're wired in parallel. You have it says here that there's 4 emitter resistors, 1 for each transistor, but I don't remember seeing that on the on the heatsink itself. It kind of makes me wonder. I'm gonna have to go back and look at that. I'm not sure about that. So it's using a dual output configured output stage to get the extra current for the 100 watts per channel, and this is good that it provides a lower impedance, output impedance for the amplifier. 7 transistors mounted on the heatsink. We got the 4 driver the 4 output transistors and the 2 drivers, and then we have a biasing transistor that's mounted here for thermal feedback. And the rest of the circuit mounted on that little fiberglass PCB board is all contained here. It's pretty typical for an amplifier. And then from the output stage goes straight into your output filters. There is a 5 ohm 5 watt resistor to ground, and that's fed through a 0.1 microfarad capacitor. I guess they put that in there for some high frequency load. Maybe the amplifier goes unstable if there's high frequencies and there's no load, so maybe that's why they put that on there, just to give it a bit of a load. The rest of it is all display board. Really not much to talk about here. It's all discrete components except for there's 2 op amps. There's a 741 here, 741 here, and Darlington transistors to turn these LEDs on and off. The ratio of which these transistors determines which transistor comes on first and second, third. So they're using it like a ladder. As the voltage rises, more and more transistors turn on. Pretty simple. Nothing to it. There is thermal protection. Let's go back here and look at this. This is a thermal switch, and it's mounted on the back of one of the output transistors to sense the temperature. And if this switch hits a predetermined temperature, it'll open, and that actually breaks the connection back here in the power supply circuit in the primary. So if that switch opens, it breaks this input voltage, and then the channel will go dead. One thing to note, there is no speaker protection, none. Some will have a fuse, some will have a circuit breaker, some will have voltage sensing circuitry to sense a DC offset, but here there's absolutely nothing to get in the way of all that sound. There is 2 diodes, reverse bias diodes, and I guess that is to prevent maybe reverse voltages coming back from the speakers, maybe. That's my guess. But I might be wrong. Okay, not much else to say about it. The big thing here is there's no speaker protection whatsoever. I ran this amplifier on my speakers. My speakers have built-in protection. They have there's 160 watt speakers, and then they have a limiting circuit breaker inside, so I wasn't worried about it. But anytime you want to run this amplifier, it's a good idea to get a voltmeter on the outputs to check, make sure there's no DC offset and the amplifier is healthy. Alright, I'm set up to do the DC bias adjustment. I discovered another problem though, and this is quite unexpected, but look at this. You can see that on the camera. For whatever reason, let's Looks like it's not getting current, but we'll deal with that. We'll fix that in a second. Let's get this idling current set up. They say to, in the book, let's see here, on the very last page there's like a footnote. There's only one adjustment, the idle current pot VR1. This adjustment is to be made with no signal, no load. It should be set for 70 millivolts DC across the two half-ohm emitter resistors, R3, R4, when the set is warmed up. So they tell you to collect a floating voltmeter, make sure that it doesn't have a grounded negative, and connect between transistors Q5, Q6, the emitters, and don't short because you'll be changing expensive semiconductors. Yeah, so what I did is I hooked up a voltmeter. You can see it up in the corner, and I turned it on. It started out low, about 16, 18 millivolts, and then it slowly climbed up to about 80, and then it settled back down around 75 where it is now. And I'm currently consuming from the outlet between 57 and 62 watts, and it's floating, it's going up and down. So I suspect that this is just you know, adjusting itself and with the thermal mass and stuff. Let's see if we can get a screwdriver, if I can find a screwdriver. There we go. And let's adjust the left channel for 70 millivolts. Didn't take very much of an adjustment. Let's crank it back up a bit right there. Let's leave it there and let it settle. What I'm going to do is I'm going to move the probes over to the other channel, and we'll do the same thing. I'm going to shut this off first. I don't want to risk blowing anything up. If I can see here, I can connect where the resistors are. Okay, got that one. Let's get this one. Alright, turn it back on. This one's low. They are getting warm. These are big heat sinks, so they can take a lot of heat before they start to rise. So we'll let that settle. It's around 45, 40, oh sorry, 50 right now. Okay, I think that's going to be it for settling. It's around 64 millivolts. It should be 70, which isn't far off. So I'm just going to tweak this one up a bit. And in case you're wondering, 70 millivolts across a 1 ohm resistor, well there's two half ohm resistors in series, that equates to 70 milliamps through the output transistors. Now there's two pairs of output transistors for each channel, so you have to take into consideration that 70 milliamps will flow through one set of transistors, 70 milliamps will flow through the other, and that consumes about 20 watts per side of idling current. So 40 watts total, and right now I am at 57 watts. Well, it jumps to 61. And then it drops to 57. So I think there's some regulation going on here that's maybe a little coarse. But, you know, if we can calculate that there's 40 watts being consumed by these two amplifiers in idle, the rest of the current, or the rest of the power that's used is probably losses in your transformer and lamps and stuff like that. But it's at 70 now, it's staying stable. I'm just going to check the other channel. To be quick, I'm just going to do this with it powered on and be very careful. And I just want to test this other channel to make sure it hasn't drifted from where I set it. And I'm getting, what's going on here? Connect these up properly. And it's about 70.9. I'm going to leave it like that. So now we're consuming 59, 58 watts. The adjustment wasn't far out from when I got the amplifier, so I didn't change any parts. All I did was I removed all the transistors and removed all the mica washers and put sill pads in their place and cleaned it all up. Okay, so I think we're ready to do some power tests. I still want to fix this display that is not working for some reason. We'll do that right now. So yeah, I don't know what's going on here. I pulled out, I think I had one fuse that wasn't making connection. No, fuse is good. That's with one fuse removed. How is that working? It's weird. Okay. I don't know. I don't know why it suddenly came back. All I did was pull the fuses and test them, so maybe it was a bum connection. There's nothing loose here. I checked the board over and it's been soldered, and I replaced these two caps. Even though they were good, I still replaced them with brand new ones. So I don't understand this. Anyways, let's get back to our power test. So we're about to do the first power test on this. It's powered up. It's hooked up to my scope. Let's feed it a little bit of signal. 1000 hertz. Let's turn up the amplitude. We gotta plug in some signal first. Otherwise, we're just farting in the wind. Okay. There we go. So we should have a signal now. There we go. Let's see. I hope that's not. That left channel looks noisy. But we're just barely feeding in a signal here. It might be just background noise. Let's try. There we go. My probes, are they set to 10 times? Yes. Yes, they are. Okay, so let's just keep going up. I'm at 11 volts RMS output right now. Just gonna keep going. .2 volts RMS. Where am I at? Probably around 50 watts. Let's just keep going here. Okay, I'm at clipping there. both channels clipping, and I'm feeding it 4.2 volts, and I'm getting 32.8 volts RMS on the outputs. Let's let this cook for a while. Full power output. It's very quiet. Usually some amps make a lot of noise when they're stressed. Gotta be careful, there's 125 volts DC in this across both rails, so you just don't want to be poking your finger anywhere. We'll just let that cook for a while. And we are consuming 330 watts out of the outlet. Okay, let's take this down. Let's increase our frequency to 20 kilohertz. Where are we here? Frequency. 20 kilohertz. Let's see how it does at 20 kilohertz. Clipping, back it off. 4.3 volts input. I'm getting 33.1 volts out at 20 kilohertz. This thing's holding its own. It's getting warm. It's starting to get warm. But this is hot. The dummy load. Sounds good. Let's try square wave. Let's see what kind of rise time we get out of this. 1 kilohertz. So that's 2 microseconds of division. Rise time isn't that. Let's slow this down. Okay, we're at 30 volts RMS out. And 2 microseconds to rise. Let's look at the other. So probably about 2.3 microsecond, or no, that's probably about 3 or 4 microseconds drop time. Let's turn this down. We don't need it blaring so loud. Let's turn up the frequency. Kilohertz. Same. And then on the leading edge, it's the same. 19 volts RMS. So we got 19.1 volts RMS on the on my meter. This is measuring 2 volts, 2 volts. You can calculate the slew rate. 2 microseconds of division, and it's 2 volts of division. Now my 10 times probes. Well, you math geniuses out there want to do that, that's fine. I think it's pretty good. Alright, so that pretty much concludes this one. This amplifier is running full power right now, and I can walk away and let this go all day long. It has no problems whatsoever with a load. It's built to withstand abuse, to put it mildly. But it's a good amplifier. I had troubles with the stereo bridge switch, which I cleaned, and it seemed to smarten up, but I could not get a measurement because the outputs are grounded. This thing is, well, let's just say it's interesting the way they designed it. There's no ground wires in this thing whatsoever. All of the ground connections are made through the chassis. This module has a plus minus 55 volts. It has a wire for speaker output, and it has a wire for the input signal, and that's it. And that's it. There's no ground wires whatsoever. It all relies on grounding through the chassis. There's a star ground right here in the middle between these 4 caps, and everything's taken from here. And yeah, it's interesting design, but I can't wait to hear it. I want to hear what it sounds like. As far as the scope goes, it should sound good. You know, 20 kilohertz. I only tested up to 20 kilohertz. I should have taken it up to its bandwidth up to, I think it's 65 kilohertz or something like that. But be looking forward to test driving this one. Alright, so that's it for this. I got another power amp coming up. It's a PA 2100, and it's not quite as built as this one, but it's still a good amplifier. We'll try that one out. I don't know when that's coming up. Pretty soon, I hope. I have a lot of HK gear to get through. I got a Pioneer being delivered tomorrow, and I got some other interesting stuff on the go. So I hope to see you again. Alright, thanks for watching.